Hey, let's keep going, huh? Let's continue our journey, and let's do that with IntelliJ. I'm going to set up the screen here, or I guess I already did, that on the left-hand side, I've got some of the slides or concepts that I want to show you, and then on the right-hand side, we've got IntelliJ ready to type as we go through some of these slides. So I'm suggesting that you set up something pretty similar, that you have a chance to type as we're going through some of these things, and if there's any time where I'm going too fast, just hit pause and make sure that you're typing this and getting used to some of these concepts, and not so much just by viewing, but actually typing. All right, so let's get into it. Let's take a look at some of the key language elements of Scala. Let's start off by, I'm going to go on IntelliJ here. I'm going to go in main under Scala. I'm going to right click. I'm going to go for a new worksheet. I think I'll call it a new one. And we can be all set then to start typing. First and foremost, let's start with expressions. This is just a way to write variables that are evaluated at runtime, and also checked at the compiler to make sure that it's kosher for the types of arguments. We can write some examples like mathematical expressions like 1 plus 1 and get a result of 2. We can also do some expressions that evaluate to a Boolean, like is 1 greater than 0? It is not. Is 0 greater than 1? I think I said that 1 is greater. It is 1 greater than 0 is not. I think I just said that, and that would be wrong. 1 is greater than 0, and 0 is not greater than 1. But you can see here the point that I'm trying to make is expressions can be evaluated to types. And what we've seen here is an evaluation of an expression to a type of integer, and then we've also seen an evaluation of expression to Boolean. So I think that's enough on expressions. You'll see this over and over again. Let's move on to values. These are named values, or create an expression with a name. So let's look at an example. Let's create a value called 1, and we'll assign it to the value of 1. Next, we can create another one. Val add equals 1 plus 1. So we can create a value that uses a previously defined value. Now notice we're using the keyword val here, because what happens if we say, actually we want to create add equals 2 now? And you'll see the red underlines here in an IntelliJ, and if we highlight over it, it tells us on a reassignment to val, which must be illegal because it's all red. And that is true. When we use val keyword to give an expression a name, or create a name value, it is immutable. And immutable means it can't change. Once we assign it, it cannot be reassigned later on. So that's why we have a reassignment to a val error here. Immutability in Spark and in Scala are a basic tenets. You try to be as mutable as you can. And that's just something that if you're new to immutability, if you're new to functional programming, this will be foreign at first. You'll be used to doing loops with I++ that has variables that are changing throughout. That really isn't encouraged in Scala. It's still allowed. You can still do it if you create variables with var instead of val. So for example, if we would change add to a var, we'd suddenly see that that is perfectly fine then, that it passes the compiler checker. So you can use val or var if you need to create a mutable variable, or a variable that you expect to change. Okay, moving on. Let's talk about creating functions. We do that with the keyword def. Let's create one called add1 with one argument, and that argument will give it an assignment that we expect it to be referred to as m, and it has a type. M has a type of int. Next, we'll explicitly define the return type of add1 by saying :int. Then we'll actually define the function itself where we say m plus 1. So we have created a function called add1 that has one argument. We have assigned that to m, and we can do this to anything. I mean, we can say x, y, z as what we want to refer to that argument later on in the function, and then we've implemented that later on. We have, in this example, explicitly defined the type of :int, and in some cases we don't have to do that. If the compiler can pick up from the definition and it can, without a doubt, determine that the type from the body of your method or from your function, we don't have to explicitly define the type. Or we can, even if it does define it, we can explicitly define the type to help people reading our code potentially. So we've got add1. We can define another function like 3 that calls the existing function with an argument. There's nothing wrong in doing that. You'll see that. Then we can call 3, and we can expect to get a return value of 3. See what we did there? 3, 3. In Scala, if you have defined a function with no arguments, as we have done here with 3, we don't have to explicitly call it with the parens. It is just perfectly fine to call 3. So you will see that. And that's it for now on functions. We'll see that again and again. Next, let's move to anonymous functions. This is where we can create a function that we don't explicitly name, like we have named in the previous examples, like add1 and 3. Instead, we can create one that's anonymous, or it doesn't have a name. That's why they call it anonymous. Whoa, that was 1 plus m. Let's tidy that up a little bit. And we have now just created an anonymous function that has one argument, function 1. Let's see what happens when we have m int n int. And we have m plus n. Function 2, function 1, function 2. This will come up again when we talk about tuples. Tuple 2, tuple 3, tuple 4, etc. Okay, so we have now created an anonymous function, and we can use this if we need to sometimes, where we pass an anonymous function to functions that expect a function as its argument. For example, map and flat map. You'll see where we pass often anonymous functions to when we use map and flat map. Don't worry if that doesn't make entire sense yet. It just takes some repetition. Functions being passed to functions. Sometimes these functions will be explicitly defined with a name. Other times they'll be anonymous. If we want to format our functions, we can use brackets as shown here on the last line of this function, and then also up here at the top. So we can cut and paste this. Let's put this into our worksheet. Oh, it did not cut and paste very well for us, so we might have some problems here. I will break this up. Hello world with the function, but then we'll close it. We still have an issue here. I times 2. Oh, that's because we've got 2 expressions on the same line, which is not cool to do in Scala. I think we can fix that if we just add that to another line. If you want to, well, since we're here, if you want to have multiple expressions on the same line, you can also separate it with a semicolon, and that's fine too, or just add another line. So formatting brackets, that should be pretty quick and easy. You can do the same thing here for anonymous functions. as we're showing on the screen. And we're moving right along. So let's see. Let's take a breath. I know I could use one. I've been talking a lot. But are you feeling all right? We're making some progress here. We've gone over a lot of things. Vals versus vars, defining functions, anonymous functions. We're working with IntelliJ in a worksheet. We're moving along. Hopefully you're feeling pretty good. Let's keep going, or pause the video if you need to. Next, let's talk about partially applied functions. This builds upon some of the previous examples. I am going to keep going here. We're going to have an adder function that has an argument, the first one of an int and also another one of int. So we've got a 2-argument function here. Let's define the body of this function, m plus n. Notice we did not explicitly express the return type because the compiler was able to determine that that was fine, that we were able to do it. So let's just roll with that. Are we cool? Are we cool with that? Are we cool with that? We can then create a partially applied function by calling add2 and then calling the adder function with 2. Where do those brackets come from? And then the underscore, which we see often in Scala. And I would define that, I'll just fix this, as whatever is immediately in scope. So that is going to be dependent upon how we use this. We can say that what is in scope needs to be an int. We're explicitly defining the type here that must be in scope. And we are calling adder, but it's just partially applied. We should see that here. That is a function 2. So if we actually wanted to do this, if we wanted to call this or use add2, we could do something like add2. What is immediately in scope? We can say, how about 3? And in that case, we should get a result back where we have now called adder2. But there's something wrong here. No, it should be fine. Ooh, times 2 must have some formatting errors on. This happens a lot when you can cut and paste from documents that are from like Keynote or PowerPoint. You'll have these illegal characters that come in that you've got to clean up. So I'm going to do that now, and I think we can get this better. Often these quotes they look like it too. Let's see if that fixes things up. Little character times 2. U28. Where is that character? Guess this isn't so bad if you're cutting and pasting. This will help. At least I hope it does. What doesn't it like times 2? Where did I miss it? Where did I miss the character? Let's simplify. Let's go like this. New code. And I'm going to do this, but I want to show you when you see me run these commands, this is me doing command // I'm going to do Command S to save it. Hello world. This is just annoying. So now I've typed that by hand. It does not like what I pasted in there. How are we doing now, people? Finally! Thanks for hanging with me there. Cutting, pasting can cause all kinds of troubles. You just saw it there. Where were we? I think we were talking about partially applied functions, and that we defined a variable add to. It's a mutable that we're passing. It's to the partially applied function of adder2. And the reason why it's partially applied is that it cannot be evaluated because the adder function requires 2 arguments. And in this case, we are saying we can't evaluate that until we pass in whatever's in scope to add 2. The way we do that here is shown here, where we pass in a 3. And just for example, if we pass in a 2, we would see a different result of 4 over here. So this is one way. Why would we want to do this? This is one way of organizing different functions or making them more abstract, and a way to potentially to promote reusability and segment your code into ways that aren't repeating itself over and over. I guess that's the best I can do for now. It's also a way to make the code more complex at times too, and it will force people new to Scala to read it and be confused. At least I was confused at first when I was looking at this. Okay, partially applied functions. Next, let's talk about, what are we talking about? Curried functions. Curried functions, one formal definition is taking the evaluation of a function that takes multiple arguments and evaluate it into a sequence of functions, each with a single argument. What does that mean? That's probably best described with some examples. Let's create a curried function then. So we do that with multiply. We'll have the first one argument be a type of int. We'll assign it to m. The second in the sequence we'll call to the multiply curried function is n. I'm not going to make that uppercase though, n, and it's also type int. We will explicitly define that as a return type of an int, and the body is defined as m times n. Okay, so how do we call this? We can call it with multiply 2, 3. We should get a result. Multiple. No, we want to call it multiply. We should see a result of 6. So that's one way we call it. We can also call it times 2, or let's just go off script a little bit here. Let's say val even. We're going to make every number even, and that will be defined as multiply 2 is the first argument in the sequence. And then let's say that we're going to make the next argument anonymous, and it's going to be based on the scope of how we call even. Remember how we showed that before with a partially applied function? Let's do that again. Let's say then even, we'll pass it an odd number. What happens? Ever. We can't call it even, ever. Let's call it even. We've made 3 even. Now let's call it a 7, another odd number, and we'll make that even. See what we're doing there? We're making odd numbers even. Fancy pants. Okay, let's do val times 3, and we can change up the order, the sequence of the curried function. So times 3 equals multiply, not multiple. We want to have the first in the sequence be dependent on scope times 3. Let's pass in a 3. Let's see what happens. No result over here on line 41. Let's give this a nudge. Missing parameter type. Sometimes the Scala compiler can be tricky and complain. Now it didn't complain at all with val even. Let's see if we need to be explicit in our type. We do. So sometimes we have to be explicit in our type in our arguments. So that's what we had to do here. So let's take a look. That's how we fixed it, even though we were able to get away with it in this first one. So times 3, and we have now called curried functions. Again, if we go back to the definition, it's taking the evaluation of a function and turn it in that takes multiple arguments and passing in as a sequence of function, each with a single argument. Curried function. All right. Variable length arguments. This one's a little bit easier. This is what happens if we want to define a function, but we don't know how many arguments will be passed to it. We can pass in this. We can define that. We can define that here using this splat character. And the splat character tells the compiler that we are unsure of the number of arguments. And then at runtime, for example, capitalize all here, we're showing 2 example, one with 2 arguments, and another one with 3, which the compiler will not complain about. Okay, so this section was taking a lot more time than I originally thought, so I'm going to keep moving. Got it? Splat character is a way to say variable length arguments. Types. Okay, this is a good one. This is something that screwed me up pretty good at first, too. Let's create a function called display. Let's create brackets, and we'll say K. Dear God, what is that? That is the type, so we can refer to it in the body of our function. Println S to indicate that we want to do some string interpolation here. How about that? Key. And let's close it off. We've already got the bracket here. Should be good. I don't know why we've got that times 3 still, that argument. Let's clean that up. Okay, so types. We have now defined here a function of a display. And what I want you to notice here is that we've created a function without an explicit type. In all these other previous examples, granted we have just used one type, I believe, of type of int. But maybe we could change that to be a string or all sorts of types in Scala. What we have now done is created a function that allows us to pass in different types. So let's call this. Let's say display, and let's pass in an integer of 10. This slide is evidently wrong. We'll fix this slide on the fly here. We have now called display with a type of int. What happens if we call it with a type of string? We can see that that works just fine as well. What happens if we call in an explicitly defined? You can see that's going to work as well. Say 110 and 110. If I hit Command Spacebar, nothing. 110. I hit Control Spacebar. Control Spacebar. Control key. IntelliJ will attempt to help us here. We must have defined 1 before because it's saying that is an option in 110, and sure enough we have done that up here, and then we've also done 110. So let's say we can also do with 110. Anyhow, we have now created a function with a generic type of k. One of the things that I was often confused about is that k relevant, or can I do anything? Can I create an L? Yes, I can create an L, and that's just fine. Can I create lowercase L? When I look at Scala, I always see lowercase. That seems to be fine too. This is convention, that when we're going to do generic type, we use a capital letter. But as you've seen, nothing prevents you from not doing that, and there's nothing preventing you from doing other letters. You will often see T for type in the code that you see. Okay, we have done a lot here now, and we've taken up a lot of time. Where are we now? We are at the point of needing to take a break. So let's take a break before we move on to some other things, all right?